Hi, I'm Sara Bowman. I'm a project manager at the Center for Open Science. We are a nonprofit tech startup. Those words don't go together, and I usually get a lot of strange looks. But that's what we are. We are a mission-driven organization with the mission of improving the openness, integrity, and reproducibility of scientific research. So we were founded in March of 2013, so we just turned 2 years old. We're primarily foundation funded. The Arnold Foundation is our major funder. We've about 30 full-time employees and about 30 interns as well. About 2/3 of our staff are software developers. That's where the tech startup comes in. We build workflow tools to help researchers manage their entire research workflow, all aimed at improving the openness, integrity, and reproducibility of scientific research. So our origin story, we were founded by Brian Nosek, who is a psychology professor at the University of Virginia, and one of his grad students, Jeffrey Spees. They noticed that they had an issue in their lab with reproducing some results. It made them wonder how widespread this problem is. And so our main platform, the Open Science Framework, became Jeff's PhD project. So the center builds the Open Science Framework as part of its infrastructure division. We also operate in 2 other areas, metascience and community. Metascience, we study the science of science to understand better what best practices are that lead to reproducibility of scientific research. And we also work in the community realm, where we build communities of journal editors, publishers, individual researchers, funders, anyone who has a vested interest in the reproducibility of scientific research. So I'm going to talk to you about kind of what we do on these 3 areas of operations. Here are some examples of recent publications getting at the issues of reproducibility in scientific research, and this kind of goes across all fields. The top left is from organic chemistry, the bottom is from drug discovery, more cancer research and drug discovery. The issue of reproducibility across the literature, across all scientific domains, is becoming more and more prevalent. And researchers are concerned about it, funders are concerned about it, and of course, publishers are concerned about it. They want to make sure that the research that you're publishing is reproducible and is valuable. So at COS, we try to approach this problem through those three different areas. The first is infrastructure. So we want to provide the technology to enable changes that will lead to greater reproducibility of scientific research. And we really think that increasing the transparency and openness about the scientific process can lead to greater reproducibility. The problem is that a lot of researchers don't necessarily have the resources or the technology to make the research more transparent. They don't know where to start. So we have built this platform called the Open Science Framework. It's a free open source web app, osf.io. You can go there and create an account right now if you wanted to. The idea of the OSF is to support the entire research workflow, starting from planning through planning to data collection to data analysis, reporting, archiving, and then finally discovery. So this is so the idea here is that the researchers can use the OSF through the entire research lifecycle, and then use it to collaborate, use it to document, use it to archive their process. So this is what a project would look like on the Open Science Framework. You can see at the top of the screen the name of the project. It lists all of the collaborators. The researchers can work together on their projects through this web app. It logs all actions that researchers take. You can share materials, share your data, document the entire process. We enable version control through the OSF without researchers needing to learn to use Git or some other version control software. As long as you upload a file with the same file name, the OSF will keep track of each of those files for you. So if you're writing a paper with your collaborator and you send it to them and say, this is the final manuscript final Word doc. And then your collaborator makes some changes to it and sends it back to you, and now it's called Manuscript Final version 2. You don't have to worry about that anymore. You just upload it here, and you can keep track of every version. We design the OSF to be used either publicly or privately. So if your researchers are concerned about sharing things before publication, they're worried about getting scooped, you can work entirely privately. Every project on the OSF has privacy controls. You can also create a component within a project that has separate public or private settings. So if you have some proprietary data or something that you can't share publicly, you put that in a different component. And then we incentivize the openness. So our idea is to meet researchers where they are, and not all researchers are ready to be completely open, but we provide little nudges along the way. So I showed you the version control earlier. You can also see how many people have downloaded each version of that paper. So if your research is public and people keep downloading it, you have a better idea of your impact. You can also see who's been looking at your project or who's been linking to your projects. All of this to try to incentivize researchers to be more open about their process and about their products. Every project on the OSF is given a unique persistent identifier. We have a preservation endowment in place to keep, if we were to go out of business, all of your data would remain up, and your URL would still direct to your project, and it will always be that way. That makes your research citable. We also just started issuing DOIs, so if your authors are people who need a DOI for their data set, we can do that as well. We also offer a feature called registration, which creates a time-stamped frozen version of your project. So if your authors want to keep track of what their entire project looked like when they submitted it for peer review, before the reviews have come back and they've made any changes, you can make a new version that's time-stamped and frozen, and you'll always know what that project looked like at that point in time. Some authors will also use this as a way to register a hypothesis or register an analysis plan before they've conducted any work. And then the way that we like to try to meet researchers where they are, as I mentioned, with merging public and private workflows. Another way that we want to do this is we want to connect services that researchers are already using. We don't want to make them learn something completely new. If there's a product that a researcher is using that works well for them, we want to connect to it through an API connection. We're not interested in reinventing the wheel. If it works well for someone, we think they should keep using it. So we have a variety of add-ons. Right now, Dropbox, Box, Figshare, Dataverse, tools like those. So these are some of the tools that we connect to now, but you can imagine in the future that we could connect all parts of the research lifecycle, and that might include publishers' manuscript submission systems. So a researcher could use the OSF to do their research, and then with a click of a button, submit it to the publishers for peer review. So that's our main platform. The next area we operate in is meta-science. We want to understand best practices of what makes science reproducible. So we have two main meta-science projects. One is a reproducibility project in psychology. You can see at this URL right here. This is the Reproducibility Project Psychology OSF project, where all of the data can be found. They have been working to reproduce 100 important findings in the psychology literature. And you can see there are quite a few contributors on this project, 266 to be exact. This is mostly a crowdsourced effort. We're submitting the meta-analysis for peer review tomorrow, so this will be coming out soon. The other reproducibility project we're working on is in cancer biology. We're working to reproduce 50 important findings in the cancer biology literature. And we're working in collaboration with Science Exchange, who is, Science Exchange is an organization that connects researchers to contract research labs or core labs to do replication projects. So we're working with Science Exchange on this, and eLife is our publishing partner. So you can check out that website for more information on that. And then our final area we work in is community and building communities of researchers and stakeholders in the scientific enterprise. So we've three projects in the community realm that I want to tell you about. But to kind of set the stage, we're interested in how incentives and the current process of publishing can affect the reproducibility of scientific research. So this is a study that shows publication bias, essentially across all of these fields that are listed here: geosciences, chemistry, social sciences, material science. Across the board, 70% of publications show positive results. The null results don't get published. So as a researcher, I'm not incentivized to write them up because they're not going to get published. And I'm also disadvantaged then. I spend some time redoing things that someone else has already done and didn't work. So that's one issue that we want to tackle. And kind of a consequence of that is because I'm incentivized to find the positive result to get published, also in a way incentivized to maybe make some questionable research decisions, right? So this is how the scientific method should work. You generate your hypothesis, you design your study, collect your data, and then analyze your data and move on. But there are certain areas where you can short circuit this cycle, such as maybe p-hacking. So I'm going to collect data until I get a significant result, and then I'm going to stop. Or I'm going to collect my data, I'm going to see that I'm really close to a significant p-value, and I'm just going to get a few more data points so that I can have that positive result and get it published. So there are a few projects working on to get at some of these issues. One of them is registered reports. So registered report is a different format of publishing. So you might think about scientific research now as study design, collect and analyze your data, write up your report, and then you publish it. And peer review comes in here at the end after you've written your report. But in registered reports, you can move peer review to after the study design, but before any data is collected or analyzed. And the idea is that the peer review is focused on the study design and methodology and the soundness of that. If that study design passes peer review, the author is guaranteed in principle acceptance of their article regardless of the outcome. So if you get a negative result as an author, you're still going to get published as long as you followed your study design or you have a very good reason why you didn't. So there are 16 journals that are publishing registered reports or some format of registered reports. None of these journals do it exclusively as their only format, but it is an option that they give their authors. And the first, the pioneer of this really is Chris Chambers, who is the chair of our registered reports committee. We have a registered reports committee of interested community members and journal editors who are proponents of this format. Chris is a section editor at Cortex. They've been doing registered reports for almost a year now, I think. So there are lots of resources on this website that Chris has put together to help editors understand how to work this into their workflow, to help authors understand how they can find journals that publish this type of publication. So I would encourage you to check that out. These are some of the journals that publish registered reports. Like I said, eLife is our partner on the Reproducibility Project and Cancer Biology, and all of those publications are in the registered report format. Our community effort in terms of incentivizing some better practices for researchers, one of these is badges to acknowledge open practices. The idea is that if you share your data or you share your materials or you pre-register your research, that's an effort, that's an extra step that you as an author are taking to say, I really stand behind my research, I really think my research is reproducible, I would like you to have all of these materials so that you can try to reproduce my work. But authors don't often get credit for that. So we've developed this badges project. There are 3 badges: open data, open materials, and pre-registered, to indicate that an author is sharing materials or data. This is a good way for a journal that doesn't want to issue a data sharing mandate. You're worried, if I require my authors to share their data, they're just going to publish somewhere else where they don't have to. Well, this is a low barrier to entry. This is the carrot over the stick. So the badges appear in a publication. Just breeze through these. So this is Psych Science was the first journal to adopt this. The badges, you can see them at the top underneath the title and the author list. So these will appear in the table of contents, they'll appear at the top of the manuscript, and then they'll always have a permanent link to the data or to the materials. The only requirement for a data or materials badge is that your data or materials are available in a public repository. It can be any public repository as long as it has some persistence. It can't go on an author website, for example. So Psych Science started this about a year ago. They went from 0% data sharing to now 25% of their publications are receiving the Open Data Badge. So we consider this to be a pretty good success. And we've had some positive author feedback on it, which authors say, of course, I would share my data. Why wouldn't I do that? Especially if I get some extra recognition for it. So the badges right now are just flat images. We are looking for publishing partners who would be interested in developing a baked badge, which is a badge that has metadata in it, so it's digitally verifiable, so that you could link right from the paper to the data or the materials. And then the last thing that I wanted to tell you about that would be of interest to you is transparency and openness promotion guidelines, or the TOP guidelines, which is another community effort aimed at enhancing openness and transparency around the research process. This is the output of a meeting that we held last November in collaboration with Science Magazine and the Berkeley Initiative for Transparency in the Social Sciences. So we invited some journal editors, publishers, and funders to our office for a 2-day workshop where the group wrote author guidelines that journals can easily adopt as is. The guidelines can be found on the Open Science Framework. They are broken into 8 different substance areas around data citation, data sharing, material sharing, pre-registration. And then they're also broken into levels. So you have a baseline level and then level 1, 2, and 3. So you can look at where your current journal policies, your current author guidelines fall into those categories and increase your commitment to openness by going up a level. We are submitting this as well for publication, so it should be published soon, but the guidelines are all available and you can read them as well as the introductory paper. So if anyone has any questions, I think I talked really fast. I'm sorry.
Thanks so much, Sarah.